Welcome back, guys. Today we'll be doing a revision exercise on trigonometry. Let's get into it. Here we're going to find the maximum value of 6 plus 2 cos x minus 30. Now, 2 cos x minus 30. To find the maximum value of this curve, it will be the value that is in front of the cos. So r in this case is 2. So it means I'll have 6 plus 2 where r represents the maximum height. So my answer is 8. The next example we will be expressing as a product cos 3x minus cos 5x. Now we will be using an identity to do this question. Now we know that cos A minus cos B is equal to minus 2 sine A plus B over 2 times sine A minus B all over 2. Now, looking at this, we know that A is 3x and B is cos x. So substituting this, we have sine 3x plus 5x all over 2. Then we have sine 3x minus 5x all over 2. My next step is to simplify each of the brackets. So where I have 3x plus 5x over 2, 3 plus x plus 5x is 8x, divided by 2 gives me this 4x. Same case here, 3x minus 5x is minus 2x, but divided by 2, I will get minus x. Now, please note that sine of a negative angle is equal to minus sine x, and cos of a negative angle is equal to positive cos x. So it means thus, here where I have sine of a negative x is minus, so the negative and negative will cancel. So I have positive 2 sine 4x times sine positive x. So the minus would go outside. So the negative cancels the minus 2, so it just becomes positive throughout. So that means the answer is 2 sine 4x sine x. Now this example is asking us to find out what is sine 2b. Now we know that sine 2b is equal to 2 cos b sine b. Now we're given that A is acute and B lies in the third quadrant. The information I need is B lies in the third quadrant. So given that cos B is equal to negative 12 over 13, I am going to use that information to find out what is sine B, because I need it in order to find out what is sine 2B. Now, we are given that cos B is equal to negative 12 over 13, so that means 13 is the hypotenuse, and negative 12 is the adjacent side, and if you realize, we're on the negative x-axis. Now, the opposite side should also be negative, because if you look at it, we have to use the Pythagoras theorem to find out what is, let's call this opposite side x, which should be negative. So we have 13 squared, which is 169, and we square the negative 12, we get 144. But once it goes over the equal sign, it becomes positive 144. So subtracting this, we have 25, but because we're trying to find out the opposite, we have to square root both sides. So the opposite is 5, but because of the position third quadrant, it will be negative 5. So just because it's in the third quadrant, it is negative 5. So it means I can now find out what is assigned to b by substituting the information, because by now we know that cos b is negative 12 over 13, and we just calculate opposite side. So this will assist us in finding out what is sine b. So sine b is equal to sine b is equal to negative 5, which is the opposite, over 13. So substituting this information, we have 2 times cos b is negative 12 over 13. So I'm going to have my negative 12 over 13 times sine b, which is minus 5 over 13. So having this information, calculating this, 2 times, well, 13 times 13, that's 169, and 2 times negative 12 times negative 5, that will give us 120. So it means our answer is A. Now, the next activity, we're given that A is acute, B lies in the third quadrant, and we need to find out what is tan A. So in this case, we just need to note that A is acute. Acute means it's between 0 and 90 degrees. So it's the first quadrant. All angles are positive in the first quadrant, so we have positive 5 to be the hypotenuse and positive 4 to be the opposite. Now, let's find the side that's missing, which is the adjacent side. So we're going to call this x. So using Pythagoras theorem, we have 5 squared equal 4 squared plus x squared. We square the 5 squared, so it becomes 25. 16, because 4 squared is 16, but we carried over, so that's why you're seeing a negative 16. 25 minus 16, that's 9, and once you have a square, you need to get rid of it by square rooting both sides. So therefore, x is equal to, in this case, positive 3, because it's in the first quadrant. So it means that tan A will be 4 over 3, which is option A. This is due to the fact that tan A is equal to opposite over adjacent. Let me write that. So opposite over adjacent. So the opposite side is 4, and the adjacent side. So this example, we'll be writing it in the form r sine x minus a. To find r, we have to use Pythagoras theorem, where r represents the height of the curve. So we use r squared is equal to 3 squared plus 4 squared, where 3 is the coefficient of sine x and 4 is the coefficient of cos x. 3 squared is 9 and 4 squared is 16. So we add these two and we have 25. Now square root both sides. So once you square both sides, that's how we get 5, where r is always greater than 0. Now A represents an acute angle that is between 0 and 90 degrees. So to find out what is A, I will have the tan inverse of 4 over 3. 4 is the coefficient of cos x and 3 is the coefficient of sin x. So this will give me 53, and I'm rounding it off to a whole number. So it means writing in the form r sine x minus a. Substituting the values I have, my r is 5 and a is 53. So by comparing this answer that I have here, the answer is C. And that's it, guys. So for this example, we need to evaluate sine 75, finding the exact value for this. Now we have to use a compound formula. But first, let's rewrite sine 75. Sine 75 is the same thing as sine 30 plus 45. Now the identity is sine A plus B is equal to sine A cos B plus cos A sine B. So what this means is that 30 is A and 45 is B. So substituting, we have sine 30 cos 45 plus cos 30 sine 45. Now you can create a table where you can easily view that sine 30 exact value is a half, cos 45 exact value is 1 over root 2, or some persons know it as root 2 over 2. Cos 30 is root 3 over 2, and sine 45 is 1 over root 2, or root 2 over 2. Now simplifying this, 1 times 1, that's 1, over 2 times root 2, that's 2 root 2, plus root 3 times 1, that's root 3. So root 2 times 2, that gives me 2 root 2. Now the denominator is the same, so we write it as is once, then add the numerator, which have 1 plus root 3. Now the option doesn't have a third in the denominator, so I have to rationalize. So multiply numerator and denominator by root 2. So 1 times root 2 in the numerator gives us root 2, and root 2 times root 3 gives us root 6. In the denominator, we multiply root 2 times root 2, that's 2, times the next 2, and that gives us 4. So as you can see, my answer here is A. This next example, we have the angle in radians, so we convert it by multiplying it by 180 over pi. So the pi's would cancel. So what we're left with is 75. So it means cos 5 pi over 12 is the same as saying cos 75. Now we will use a compound angle formula for cos, because cos 75 is the same thing as cos 30 plus 45. So we have a compound formula, which is a compound identity, that says cos A plus B is equivalent to cos A cos B minus sine A sine B. In this case, our A is 30 and B is 45. So it means substituting, we'll have cos 30 times cos 45 minus sine 30 sine 45. Now cos 30 is root 3 over 2, and cos 45 is 1 over root 2, or some persons will write root 2 over 2. Sine 30 is a half, and sine 45 is 1 over root 2. So root 3 times 1, that's root 3. 2 times root 2 is 2 root 2, minus 1 times 1, that's 1, over 2 times root 2, that's 2 root 2. The LCM for this is 2 root 2 because it's the same. And the numerator, I'll just have root 3 minus 1. Now, none of the option has a surd in the denominator, so I'll rationalize to multiply the numerator and the denominator by root 2. So we have root 2 times 3, that's root 6. And root 2 times negative 1, that's minus root 2. All over root 2 times root 2 is 2 times 2, that gives us 4. And you can see the answer is B. For this example, we'll have to use the compound formula for cos, where cos 3 pi over 2 plus theta, we'll be using the compound formula similar to the previous one that we were using, which is cos A, cos plus B. So using that, we have cos 3 pi over 2, which is A is 3 pi over 2, and then cos theta, which is B is theta, minus sine 3 pi over 2, where 3 pi over 2 is A, times sine theta, where theta is B. Now this will be 0, so that will be gone, and sine 3 pi over 2 is negative 1. So multiply negative 1 times sine theta, that's minus sine theta. And negative, that's plus. So it means the answer is positive sine theta. So the next activity is to determine the quadrant that sine theta cos theta belong, where sine theta is positive 3 over 5, but cos theta is negative 4 over 5. So we can draw the cast diagram, which tells us, since we want sine to be positive and cos to be negative, it will only be in the second quadrant that I have sine to be positive and cos to be negative. So the answer is the second quadrant. If we wanted both angles to be negative, then it would have been the third quadrant. Our next activity is be finding out what is the equivalent of cos 60. Now it is a compound formula that we use, so cos 60 is equal to cos 80 minus 20. So it means that is equal to cos 80, that's a 20. So it's equal to cos 80 cos 20 plus sine 80 sine 20. So the answer is A. The next activity is asking what is the amplitude. The amplitude is 3, is always a number in front of sine. Now our final activity, we need to find out using which compound angle is a compound angle that looks exactly like this, which is the cos A plus B. So that means A is 40 and B is 30, so it's 40 plus 30, which is 70. Thanks for watching, guys, and don't forget to like and subscribe.